Let's continue talking about crustal deformation by talking about faults. And faults are examples of brittle deformation of the crust. So with folds, it was ductile deformation, where they behave like a slice of bread. And with faults, it's brittle deformation, where they're behaving more like a cracker, something that bends and does not fold, or breaks and does not fold when it's bent. So the way that we describe faults is first of all by their offset. And we're going to start by talking about faults that have mostly vertical offset. In other words, one side is moving up, the other side is moving down. We call these dip-slip faults. And that just means one side is moving up, the other side is moving down. Sometimes they can produce places at the surface of the earth where we can actually see this offset, and that's something called a fault scarp. And the way that we describe the offset on these faults is we talk about two different sides of the fault. One is called the hanging wall, and the other is called the foot wall. So let's start out by talking about what we mean by it. First of all, hanging wall and foot wall, and then we'll describe what a normal fault is. So with faults, we have a hanging wall and a foot wall. In this case here, we can see here this area in red here, there's a fault running through it. And sometimes faults were areas where the mining was good. The water would percolate through these cracks and leave behind some deposits of minerals or other valuable materials. And so a lot of miners would be working in areas where there were faults, and they would want to describe how things were moving. So if you think about a miner in this area here and a fault that kind of isn't straight up and down, but it's just a little bit of an angle, we can see that the place where the miner would hang his or her lantern would be on the hanging wall, and the place where the miner would put their feet would be on the foot wall. So the foot wall is underneath the fault, the hanging wall is on top of the fault. So this is this entire area here is the hanging wall of the fault, and this entire area over here is the foot wall of the fault. And this is how we describe the movement of faults. So in this case here, we would say, well, this dark gray layer here used to be the same one as over here. So the hanging wall has moved down with respect to the foot wall. And that is what a normal fault is. So with a normal fault, we have the hanging wall move down with respect to the foot wall. Once again, this yellow layer here used to be up here, and now the hanging wall has moved down with respect to the foot wall. Even though we might just expect this to create a low area, sometimes on the foot wall, we can still get higher areas that are kind of mountainous because they're higher than everything else around them. It's all a relative movement, so it's not like, as one part gets lower, another part gets higher. So this would be what we would call a normal fault. And once again, the way we define a normal fault is the hanging wall has moved downward with respect to the foot wall. And the place we usually get this happening is if we get strong extensional forces going on. So plate tectonic type extensional forces can create this sort of environment where we get a whole bunch of normal faults all associated with each other. And as we get normal faults associated with each other, sometimes we get high areas where the foot wall has moved up. And you can see that happens on both sides here, right? Here, the hanging wall has moved down with respect to the foot wall, but also over here, the hanging wall has moved down with respect to the foot wall. And what we're left with is this feature which is called a horst. And if we have the hanging wall move down with respect to the foot wall on both sides of a low area, then we get something called a graben. And we can see that as we move through an area, we might get horst and graben and horst and graben, and it might just continue on as we get all of these normal faults here. Each one of these is a normal fault where the hanging wall is moving down with respect to the foot wall. It's an area of extension. This is very common in the southwestern United States. Here's a map showing the topography of all of Nevada. This is called the Basin and Range. And all of this is driven by normal faulting. So here would be a horst, a graben on either side of it. On the edges of these would be normal faults where the hanging wall is moving down with respect to the footwall. And this extends all the way into southeastern Oregon. Here's the Steen Mountains here, and the Alvord Desert in front of it there. That they're formed in the same process. That's actually the beginning of the basin and range in southeastern Oregon, and extends over into Utah as well. This is a very big area where there's been extension associated with the movement on the San Andreas Fault, but extending this particular area and causing all this normal faulting with the associated horsts and grabens to form.